Hello and welcome back to SQA Higher Maths Optimization, applying differential calculus optimization. We're going to look at question 2 here. So this time we're going to do optimization. We're also going to mix that in with a closed interval question from the previous lessons, from lesson 1 that we've just looked at. So in practical situations, there may be bounds on the values we can use. So we might be told, for example, again, I'll let you guys read this bit up here. You can do that. So in this question, the point P lies on the graph between x equals 0 and x equals 7. Okay, so there's 7 there. Here's 0 here. So this point lies on this curve. Okay, we'll find out later in the question the curve doesn't actually look like this between 0 and 7, but that is the diagram we're given in the question. Okay, the point P lies on the graph between 0 and 7. A triangle is formed with vertices at the origin P and negative P, 0. Okay, so basically we're going to make a triangle. This point P can move up and down the curve here. Okay, so if we're able to drag it up to here, say, then we get a triangle that would look like that instead. If we could drag P right along to the end, then we'd get one that goes right along there. Show that the area A square units of this triangle is given by this formula. Right, so again, never seen a question like this before. You'll not know what to do sometimes. You might have to look for a little hint, but the more of these you do, the better you get at them. Okay, so show that the area, well, what area are we finding? We're finding the area of a triangle. How do we find the area of a triangle? It is 1/2 of the base times the height. So the base, well, negative P to 0. The base would be P, because that's a distance of P. How high is this? Well, that is just the height would be given by whatever value you get when you substitute in P. So as this point moves up and down the curve, the height of that point changes, and that will all depend on the x coordinate we're substituting in. So given that we can move P along in either direction, we're basically substituting P in to get the height. So the height will be given in terms of P. We're not going to get height of 6 or height of 3 or height of 2.7. We're going to have to substitute in P to get the value here. Just like if we have y equals x squared plus 4x plus 2, if we want the y coordinate when x equals 3, we'd need to substitute 3 into x squared plus 4x plus 2. So the y coordinate there would be 3 squared plus 4 3's plus 2, whatever that turns out to be, which probably 23 if I've done that right in my head. Okay, so instead of substituting in 3, I'm just substituting in P, because P changes in the question. Okay, because in part B, find the greatest possible value of A and the corresponding value of P for which it occurs. So this value of P can change, which will also drag this back and forward. And the triangle will get larger and smaller as we move left and right. So if you notice, this distance and this distance are the same. If we dragged this along to here, so say with P was 6, because this is P as well, this would go from 0 down to negative 6. So it'd make it wider, but shorter. Okay. So the area is given by a half base times height. So half multiplied by P multiplied by f of P. So I'm just substituting P into the equation of the curve. So P squared minus 12P plus 45 is the height. Okay, so half multiplied by P multiplied by what I've just said, P squared minus 12P plus 45. Multiply through by a half P, and we end up with a half P cubed minus 6P squared plus 45 over 2P, which is exactly what we were asked to show. Right, guys, so you might have to just watch that again because it is quite a complicated topic that we're introducing. Ideally would be in class and you'd be able to ask questions, and the certain line that you're not sure about, I'd be able to go over again. Okay. If you're really confused, I'd be happy for you just to wait until you come back in the class and ask questions. Part B, I will do in a separate video.